Hey math kids, today we're going to use Geogebra again to uh, do a thing called dilation. So I'm just going to drag something from my desktop in. You don't have to go through the other process that we've been doing. Now, while we do that, I'm going to click on these points and get rid of them. And then I'm going to redraw this diagram in this program. So I'm going to click here, use the line tool, click A, click B, and that just redrew my entire line. Then I'm going to click the point tool and click on O. It's going to name it C, but that's okay. Now I'm going to click on the image and I'm actually just going to delete it so we don't get confused with which A, B, and C or O or whatever we're doing. Now what we're going to do, I'm going to dilate this figure by a factor of 4. On your assignment, I believe it's a factor of 3, so you'll go through a similar process. Now, you don't need to do this next part, but I just want to explain what you would do if you were asked to do this like on a piece of paper. So what you're going to do is essentially you're going to draw a segment from here to here, and then you're going to draw a segment that's 4 times longer, but also goes through A, and that's going to be your new dilation. And then we do it here and here, and then 4 times longer, so you'd want to use a ruler, and then we connect these and it's the dilation. Now, I wasn't precise. I didn't make these 4 times longer, whatever. So I'm going to delete these because I don't actually need them because there's a built-in dilation tool. But I just wanted you to, kind of conceptually understand how we dilate things. So I believe it's right here. Yep, dilate from point. So you're going to click the point you want to dilate, and then you click the center of dilation. So I'm going to click A, and then C. Then it asks me for my factor, and as I said, I'm doing a factor of 4. And we can't actually see where that went. There it is. So it plotted this point. Now we're still on the dilation tool. I'm going to dilate B with my center C by a factor of 4 again. And now my dilation is going to be the line that goes through A prime and B prime. Okay? Now, a couple things should happen here. And I want you to show this. So we're going to measure the distance. So first, the distance from C to B. And we can maybe move that down here. Then the distance from C to B prime. Now, it should be 4 times larger. So let's check that with a calculator real quick. It looks like it is about, but I want to see how close it is actually. All right, so we have 1.49 times 4, and we see that it's very close. Once again, there could be a little bit of user error with how I placed my B prime and my A prime when I was drawing the line, and so that's why there's a tiny discrepancy there. Now, if we measure CA to CA prime, that should also be a factor of 4. And so if I go CA and then CA prime, once again, let's check that. 1.73 times 4 should be pretty close to 6.91. Okay, once again, it's a tiny discrepancy, but it's convincing that it's 4. Now, the thing that, in my opinion, is actually more interesting. Whoops. I did not mean to do that. All right. Well, sorry about that. I did not mean to do that. I wanted to move this out of the way and this out of the way. Now, I don't think it'll mess up our calculations, me doing that. The other thing that I think is a little more interesting is that this line segment, A prime to B prime, should be 4 times longer than A to B. So that's the next thing we're going to measure. So A to B, 2.64, and then we measure A prime to B prime. So let's test that once again in a calculator. 2.64 times 4 is really close to that. Once again, it's probably user error, my fault, that it's not exact. Okay, so that should get you through those type of problems. If you need additional help, come to Math Lab. Until then, calculator.